compound inequalities, we're basically saying that we are combining two inequalities together. Just like we can have compound words in English, where we put two words together to form one word, like cupcake, policeman, okay, where we're actually combining two words together. So here for compound inequalities, you're combining two inequality problems together. Notice you'll see two words, one is and one is or. Okay, you want to write this at the top of your page. And represents the intersection, so write that down. Or represents the union, which means you're combining the two answers together. Okay, so please write that at the top of page 26. And those words, guys, are going to be very important. And or. Now, notice you'll actually see the words and you'll see or in some of the problems, but like in number 2, you don't see either word. Okay, so what do you do in that case? Because you have to know if it is an and type of problem or if it's an or type of problem. So when you don't actually see the word, it is an and. You will always see or. Okay, so I'm going to put like some eyeballs up here. Okay, you'll always see the word or. You may not see the word and. Okay, so if you don't, you know it's an and. All right, so let's take a look at the first one. So this is an and statement, and basically means this. So let me just give you like a visual. So if we're graphing two different inequalities, and let's say, we graph one inequality and let's say this is at 1, and then we have this, and then we graph the second one, and let's say that's at 4, but it looks like this. Okay, it's going in the opposite direction. So for an and statement, basically you want to know where the two graphs overlapped. So they overlap, obviously, right in this area right here, okay, between 1 and 4. So for an and problem, you would only then graph, you would put like a closed dot here, an open circle here, and you would only graph that part of where they overlap. So this is an and problem, okay, where the two overlap, and that's why we call this the intersection. Now, if you have an or problem, let me show you what that will look like on a graph. A lot of times, and ors can go in the same direction, or they can go in opposite directions. So you might have something like this. One is going in this direction, and let's say we get -4, and that's going in this direction. Okay, see how they're not even going to intersect? This would be considered an or problem. All right, and now, can they go in the same direction? Absolutely. So you have an option. You could have one going in this direction and -4 going in this direction. If that happens, let me show you what your graph will look like for your answer. You start at -4, and to include both, you just shade it to the right, because now you're including this line as well as this line, but you want to show it on just one graph, right? But I would probably say 90% of the time, and I hate to put a percentage to it, 90% of the time though, you will see them just going in opposite directions. If they're going in opposite directions and it's an and statement, it will be a no solution, because and only represents where the two lines overlap. Okay, so that's important. That's why that word and or is important. So let's just see what it looks like on your worksheet. So you're going to solve them individually. So let's just go ahead and solve the first one. So I'm just going to copy them down here. And I know it's an and statement, so I want to know where the two would overlap one another. So I am going to subtract 3 here. That will give me 2n is less than or equal to 16. So n is less than or equal to 8. And let me do the other one. Add 10 to both sides. 2n is greater than 14. So n is greater than 7. So we know how to solve, two separate inequalities, not a problem. So notice here, I have 8, which will be shaded to the left. And then I have 7, which is shaded to the right. Okay, so let me just let you see so you can see where they overlap, and then we'll do the answer graph. So take a look up here. You don't need to write this part down. Okay, but this just kind of gives you a visual as to what's going on. So let's say this is 7 and this is 8. So if it says 8 has a closed circle and it's everything that's less than that is going in this direction. Then it says 7 has an open circle, but it's greater than, so it's going in this direction. Now, we only want where we see the red and the black overlapping, so that will only be from 7 to 8. Do you agree? So when you actually do your answer graph, it's only going to look like that. You're going to have an open circle on 7. You're going to have a closed one on 8. And you would shade it in between the two numbers. So it's a very short graph. Okay. If you were doing this problem for homework or on the test, let's say, as on homework, you'll probably just indicate on math space where it is. But if you were actually doing a test for me, and if I don't have a number line, you simply just need to make like a number line, indicate where 0 is, indicate where 7 is, indicate where 8 is. That's it. Okay, then you would just make your graph, open circle, close, shade it in between. Okay, that's how you would do it on a test. Normally, I provide the number line for you, so you don't have to, put all those numbers in between anyway. But if you're just doing this on your own, don't put all the numbers that are in between 0 to 7. You don't need to do that. All right, so for set builder notation, go to the next page here. So you have an example of how we write things in set builder notation when it's a compound inequality, and I want you to be able to make some observations here. So when it's a compound inequality, notice that which number do you see written first? The smaller number. So the smaller number is always written first, the larger number is written second in every single one that you see. However, also notice this, the variable is always in the middle. Okay, so we're going to be doing the same setup. We're going to have our smaller number first, we're going to put our variable in the middle, we're going to put our greater number last. Okay, notice, what do you notice about all of these inequality symbols? Every single one. What do you notice? They're all what symbol? Yes, they're all less than or less equal. Okay, because when you're putting your numbers in order from least to greatest, okay, and you're saying it's in between this smaller number to this larger number, you always use less than symbols. Okay, so either it's going to be less than or it's going to be less equal every single time. So going back to our problem, we're going to start with our smaller number. So which one is smaller, 7 or 8? 7. So we're going to say n such that 7, and this is even though it's greater, we're switching it, it's going to be less than n, and this one has an equal sign, so it's going to be less equal to 8. So that is how you would write it in set builder notation. Start with your smaller number to your larger number, your variable in the middle, and use less than or less equal symbols. All right. 2. All right, so let's look at number 2. Now notice in number 2, you don't see the word and. So they didn't write it as two separate problems. Now, can you separate it into two? The answer is yes. Okay, so I'm going to show you how to do that. So I'm going to separate into two, but I want to actually solve it. I'm going to then erase it because I want to solve it like it is. But some students have a difficulty sometimes, so I'll give you the option. So if you want to separate it so it'll look like number one, this will be one of your problems. So let's write it down. And basically, the problem will share the middle. So this will be your second. So you'll write the 10 minus 8v again, and then less than 58. So that's how you would separate it into two different inequalities. Now I'm going to erase that because I want to solve it like it is, because I've already solved one where it's separated, and now you know what to do, just solve each one individually. So in case you want to opt to leave it like it is, I want to show you what you would do. And it's not hard. So, you know, most of you probably will opt to just leave it like it is. So I'm just going to rewrite it here. So what I want to do is get my variable alone, and it's in the middle. So I have to get rid of that positive 10. So I'm going to subtract 10 from the middle and from both sides. All right, so what is a negative 46 and a negative 10? Negative 56 is less than or equal to negative 8v, which is less than 48. So all I did first was just subtract 10 from the middle and from both sides. Okay, now I'm going to divide by negative 8. And when you divide by a negative, what do you got to do? All right, so we're going to divide by negative 8. And then we're going to reverse the symbol. So a negative 56 and a negative 8 gives me a positive what? 7 is greater than or equal to v, which is greater than negative what? 6. All right, now, this is not in set builder notation. Why? Can anybody tell me why this is not in set builder? Yes. What's not first? Something's not first. The smaller number, okay? So when we reverse it now and put the smaller number first, then we're going to have all less than symbols. We reverse all the symbols. Okay, so let's put this in set builder. So I'm going to say v such that, because that's how you start off with set builder. Start with your smaller number. Negative 6 is less than v, which is less than or equal to 7. Okay, now I'm going to go back to my graph. I'm going to go to negative 6, and I'm going to put an open circle. And then I'm going to go to positive 7 and put what? A closed circle. And then I simply shade it in between, because I'm saying that these two graphs overlap between negative 6 and 7. Okay. All right, any questions on that? Now, there are instances where you can have no solution. So I want to do one of those. So let's take a look at question number 5. Okay, everybody take a look at number 5. Is number 5 an and an or? Which one? It's and, because you don't see the word. Okay, so it is an and. So remember, and means where the two graphs overlap. So let's just see, and what you're going to see, and I'll tell you ahead of time, these two graphs will not overlap. All right, so let's work it out first. So I'm just going to rewrite it here. Okay, I'm going to subtract 1 from all sides. So I have 54 is less than negative 9n, which is less than or equal to negative 81. Okay, when I divide by the negative 9, I'm going to reverse the symbol. So I'm going to have negative 6 is greater than n, which is greater than or equal to 9. Is that right? Okay. All right. So now, if I were to graph it like it is, okay, and let's do that because I want you to be able to see that they don't overlap. So here's 9, and that's going to be a closed dot, and it's going in that direction, okay, because it says n is greater than or equal to 9. For this part, this means n is less than -6, okay, because when I have to flip it and write the variable first, that's really what it means. So if this is -6, this is going in this direction, okay? Since this is an and statement, they are not overlapping, so you write no solution, okay? They're not going to meet, okay, at all. All right, so let's go back to number 3. We're going to do only 2 of these for ORs. And then most students find ORs a lot easier because they can go in separate directions, and it's actually easier to write it in Set Builder as well. All right, so let's just copy this down to the bottom. Okay, and then the OR would be -10x minus 2 is greater than or equal to 38. All right, so we will subtract 2. So I'll have 9x is greater than or equal to -49. Oh, that is a positive, my fault. Okay, so that's going to make that a positive what? 45, okay. And then when we divide by 9, we're going to have x is greater than or equal to 5. All right, let's do the other one. We're going to add 2 to both sides. So we'll have -10x is greater than or equal to 40. I'm going to divide by -10, so I'm going to reverse the symbol. So x is less than or equal to -4. So when I graph this, let's just go ahead and graph it. X is less than or equal to -4 will be a closed dot, shaded to less than, which is to the left. And then for 5, it'll be also a closed dot and shaded to the right. And that's perfectly okay for an OR statement. Now, give me a minute. How do we put this in Set Builder notation? Okay, all we got to do is take our 2 answers, put the word OR between. Doesn't matter which one is first, which one is second, like for the AND. We just write the word OR, put our bar, repeat the variable, and that's it. So x such that x is greater than or equal to 5, or x is less than or equal to -4. All right, so this is question 4. All right, so I'm going to have 1 minus 4b is less than -15. So when I solve this, I'm going to subtract 1. So -4b is less than -16. Divide by -4, so I reverse the symbol. So I'm going to have b is greater than 4. Okay, then my OR is -5 plus 7b is less than or equal to -12. Add 5 to both sides. So 7b is less than or equal to -7. Divide by 7. So b is less than or equal to -1. All right, so if I were to graph this, I would put an open circle on 4. It'll be shaded to the right. Okay, then I'm going to go to -1 and put a closed dot. Okay, that's shaded this way, and that's perfectly fine. I'll put the word OR between the 2 answers, Set Builder, and put the set brackets. Okay. And again, if this had been an AND statement, it would have been no solution because they're not overlapping one another. Okay. All right, so your homework tonight is math space, these compound inequalities. I would definitely probably suggest writing some steps down before trying to type everything into math space tonight. Okay.